Okay, hello everyone, and as again we are back. We are back with another video of this time we are talking about design patterns. So if you can understand what are design patterns, that most of the questions for low level design are automatically solved. Okay, so why I'm saying that? Basically, I have taken around 200 interviews in the past 4 months, and I can tell you that the service-based or product-based industry, the questions are very different. In the product-based industry, they will ask you like to draw a LLD for some kind of thing like air booking, ticket booking, and all those things. And in service-based industry, they'll bluntly ask you that how what all design patterns do you know? So if you have given this answer as a service-based engineer, you would have told like I have worked with MVC, chain of responsibility, singleton, but actually they want gang of four, like the behavioral, structural, design patterns, right? So with so that's what we are trying to achieve here, and we will be understanding the simplest of it just to keep your answers intact for those 1 minute, and you are done. So you don't need to worry about anything else. So to start with, let's start with strategy design pattern. So if you come up with a design pattern, right, just take this thing as one. What can I derive from a name? You can derive a strategy for a name, and there can be multiple strategies, right? So if there are if there is one strategy, it's not called strategy. Okay, it's called a path that you will follow this. If there are multiple strategies, these are called strategies. So it is very important for algorithm if you are talking about implementing a family. Okay, suppose there are like bunch of things you have to do and you don't know which one will work correctly, so you will use the strategy design pattern. So you can select your own algo or any demands or any like solution on the go. So suppose we can say example of like storing the files, right, in different formats. So we can always in the if you have like if you have used Microsoft Word and everything else, you can see like .text, .csv. So that is how you can save, and that's a strategy here, right? How what all documents you can save. So how we do it? So we actually do take a help of abstraction. Okay. So what we do is we create an interface where the client interact with the system, and behind this abstraction we have multiple implementation for the same interface. That if and with different algorithms. So I mean, like the way we are doing, right? Like dot save is a like save is a interface, and text CSV JPG is a implementation of the interface. Then for client, so the runtime actually, the algorithm will be depends on what particular things we are asking. It's a very good question and very good answer here. So you can don't need to do anything else. Similarly, Java collections dot sort, they also use the strategy design pattern. Okay, so now we can come to what is the observer design pattern. Okay, so if you see, the observer design pattern is basically kind of a pub-sub model. So that means somebody is an observer, somebody is a subscriber, and I am like observing and I'm sending the update to the subject or subscriber. So there, I say that once there is an update, okay, in anything, any context, the observer will put everything to in place. So that is the most popular use of observer pattern will be in the model view controller architecture pattern, the MVC. So this is how it relates. You can talk about observer as like the notification and then results, right? Whenever like there is a test coming on for the students, but basically the notifications things, all those Kafka and everything is there. Now the main point is what are the main issues in observer pattern? If you can see, it is mentioned here. The main issues is observer pattern is a memory leak, because the subject, right, it holds a strong reference to the observer. So if observers are not deregistered in time, it could lead to memory leak. Similarly, like if I don't need all the information, I need to make some tweak that I don't need this, I don't need that, like those. Now, some of the examples of observer design pattern in JDK. So we have java.util.observer, observable, and we have HTTP session attribute listener, and we have in servlet the HTTP session binding listener, all implementation of Java util event listener, and also in Swing package. These are like not, I think these are removed. So all the listener and like those things, right, where you need to propagate the messages, the JDK in JDK or in anything, observer design pattern is used. Now we are talking about two things here. Wow, one is the strategy design pattern, and second is a state design pattern. So strategy and state both are behavioral design pattern. But if you can take a very closer look in the state and strategy, you can see that the state design pattern is used for defining the state machine for an object. So basically, each state of an object is defined in the child class of the state class. When different actions are taken on an object, it will change its states. I'll come to a closer explanation in some time. However, we know strategy is totally dependent on the algorithm part, like the way we talked about the dot text, dot JPG, and all those things. Now, some people consider state pattern similar to strategy pattern because the object changes its strategy based on different method invocation. But the main difference is that the state pattern is the internal state of an object, which is determining, it is one of the determining factors for selecting the strategy for change of state. Okay. Whereas the strategy pattern is you are changing the external parameters. So if you're changing the internal state of an object, like maybe what I can say, like internal mechanism, like the variables and all those things, you can use state. But if you're changing the whole pattern altogether, you can do this thing. So it's very easy to give an explanation in one line, and that's it. Uh, that state pattern is based on object's internal state, while the strategy pattern is based on the client invocation. Okay, so now it's a very good example of a decorator design pattern. This decorator is kind of a thing when you always feel like what to answer, because it is kind of, but you can take it as a makeup. Okay, makeup of anything. So the wrapper pattern, we can call it as a wrapper pattern as well. So what it does, you have an object, you want to add some external behavior without changing the behavior of other objects of same class. So that time you use a decorator pattern. So one of the very, very good use of decorator pattern is the Java IO package, right? So basically, we have a file input stream to handle a file. To add the buffering behavior, we can use buffer input stream. To add the gzip behavior, we have a gzip input stream. And to add the serialization behavior, we have if you want to do, we can decorate it with object input stream. So if you can see this piece of code, this is a file, right? This is a file which we have. Okay, myfile.gz. It's a zip file. So now we want to add buffering. So we will add the same. You are adding the buffering in this. Now you have this guy. Now you can add this. Now you want to serialize. You can serialize also. How? Using the same. So you are propagating your same object but with a different decoration. So that is a very good example. And these are the examples you should give when you are giving a explanation, and those things are very good to explain. Okay, so this is something which you should keep in your mind. Make a note. I'll also make a note of this video. So now let us go to the different question of what is a good scenario for using composite design pattern. Okay, first of all, what is a composite design pattern? It is something which represents a data. That time you can do a composite design pattern. So that means suppose a tree structure, right? Binary tree, whatever tree you can take, it represents a data. So basically, if in an organization, a manager has employees, but manager is also an employee, it's also a very good question in SQL where you want to do self join and all. If we start from CEO level, there is a one big tree, right? Under the big tree, there are many sub trees. So that is a recursion. So another use of composite design pattern is a recursion. If we have a recursion based algorithm and it need to be passed to the algorithm in a data structure, then you can use a composite design pattern. So example, if there is a polynomial solving algorithm, that time you can use it. In graphics also you can use, because we have a group of shapes. We can make a high level shape with smaller group, right? So those things can be done. That's a good question, to be honest. Now, have you used singleton pattern in a Java project? Obviously you have used. We have talked in the previous video also what all we need to be. So singleton is something which everybody knows, that it will give you only one instance every time. If an instance is running, it will give you the same instance, so it is good for a multi-threading part. But yeah, there are many ways to break it, like reflection, object cloning, serialization, even with threads if you are not handling the synchronization part correctly. So let us talk about the last question of the day. So pay very, very close attention. What are the main uses of singleton design pattern in Java project? So some of the main uses of singleton design patterns are like in the runtime. In JDK, the runtime is a java.lang.runtime is a singleton based class. Remember it very carefully. It might give you some answers or some marks, and might take you one selection also. So basically, there is a one instance of runtime, right, in every application, and that is what singleton is. Enum is a singleton pattern, so it is also good. Properties. So in an application, it makes sense to keep only one copy of properties that all the class can access. Okay. Then Spring Framework. It has default bin scope is singleton one per container, right? You have prototype also, request also, session also, but we are not going it right away. So keep a check on your task. And for this video, we are closing it out here itself. And hopefully we'll meet again in the next video. Till then, take care. Have a nice day. Bye bye.